Yes, I'm working here at Sweden University in Östersund, where it's snowy right now, which is not an exception in Sweden, I hear. There's quite some chaos in other cities too. Here it's rather calm, rather expected by the mountains. That's what we have here. Not so close to the sea though, as Sundsvall is, which is the other campus that this university is spread among about 200 kilometers to the east. Yes, I'm working with Sweden University for many years, and just this year we are starting a software engineering research group, which I'm excited about, and I'm the lead for that project, and I want to talk a little bit about that, but also mostly about the ongoing work, specifically a concrete outcome of ongoing work together with Robert Feld and Francisco Gomez in Gothenburg. And why? Because I think there's a lot of interesting potential for collaboration, both maybe to improve the things and methods we're working on, but also to utilize them. Yes, this is my outline here, short bio. Since for most of you, I'm probably a wild card. Haven't met. I know some of you. I see Michelle is here, and hi Michelle, and
hi.
And yes, then also presenting just brief info about the group, and then diving into the work in itself, and presenting some outlook possibility for collaboration. A summary of what where I come from. I'm originally from Hamburg, Germany, and I studied informatique, which is some kind of it's computer science, but it's also informatics. It's a combination of information systems and computer science. It even stretches to electronics. I don't know how this is today, but it was a rather theoretical education. And then coming to Sweden, I did very practical work in distributed systems. I took a master's there, and worked also for some years as a developer, also on partly on distance. And so that was even a thing before Corona, and this is actually partly before smartphones and iPhones. So even distance work was a thing back then. And then, as you see, I've been working in different fields. I did my licentiate completely unrelated to what I did in my PhD on computational intelligence, working on evolutionary algorithms mostly. And then wireless sensor networks, where we were investigating reliability in wireless sensor networks, which resulted in me having always cords with me now, because I realized that if you want to have good quality, that's probably what you want to do. And then moving over to software engineering, I always had an interest in programming and software development, and worked together with Robert Feld then in Gothenburg for 2 years, and which was a very interesting endeavor. And I felt that I'm stuck. I'm stuck there. I really enjoy working on these kind of issues, and also with the people in the area. And yeah, since 2016, I've been tenured here at Sweden University, and did some let's call it a sabbatical in Chalmers then. And also I've been involved, as you see, I'm doing a lot of things that are unrelated, but I've been involved in entrepreneurship, and currently working on a product that we hopefully, a service, more or less like a SaaS, that we hopefully can get out next year, which is about democratizing ratings. So about the group forming this year, very early development. Sometimes things, or oftentimes when you think of forming a group, it's your first thought is that you do it bottom up, right? You can hire people, PhD students and postdocs to do something that you're interested in. Now here's it's more of a merger between different subjects, as you see, information systems, and in terms of software testing and quality assurance, that's mostly me. And we're trying to identify something, a core of what we want to do and can do together, and impact on the actual software development within companies. And the move from university to companies is something that we look into now concretely. The gap between what we're teaching at universities and what is actually demanded in industry. And this fits well into what's been done here at the department before in terms of e-learning, distance collaboration, and also gamification. We're rather small. We have 3 PhD students currently, with 2 docents and 3 senior lecturers. Yes, we're working on a framing that will soon come out, so that even we can be like visited and display ourselves. But now about the work that I want to present. It's something that we know is not always perfect. Are the specifications of our software sometimes and oftentimes in open source. It's much of it is implicit, and there are good reasons for that. But this is just the way it is. That the inputs, outputs, requirements, and constraints are not explicitly written down. Whereas in other situations, where it comes to spacecrafts, much of this is very explicit. One of the advantages we're having when we have specification, of course, is that we can separate out the actual implementation of the software and the way that we ensure quality. And we often and usually do that through software tests in order to validate that the specification actually holds. And what we're looking into now is to extract actually information from the actual programs. In software testing, we call them SATs, the software under test, and actually feed them back into the specification. And that can both help where specification is sparse, but it can also help to actually shorten the specification that you have in order to get an understanding if the actual development and execution results that you're getting are aligned with your specification. And this can also feed back to the tests, and so we get some kind of nice quality assurance loop. And in this loop, we are including and defining a new term, which is related to some former terms that you're familiar with. Probably it's in order to ensure the correctness of software, we have to make sure that it's correct on the boundaries. And we introduce this new term, which is called boundary value exploration, or new, not that new, it's from 2020. And it relates to both boundary value testing and analysis. And this is in order to ensure that the desired and the actual behavior actually align. Another way to look upon this is that we have the expected behavior, which is actually defined by the specification, and we have the actual behavior, which is kind of what is the result of an implementation, right? And so the questions that we're trying to address with boundary value testing is whether the for specific input paths, whether the actual boundary outcome is the expected one. So we're trying to align those two. Another concept that is also a familiar concept for many is the boundary value analysis, which is more related to the expected behavior and looking into how the development process and the artifacts can actually ensure that the expected and actual boundaries are aligned. And so what we are introducing here is somewhere in between boundary value analysis and boundary value testing, which we call boundary value exploration, because it suggests candidates to be lifted up into the in front of the testers and developers in order to get an understanding of the actual behavior, and for verification if the actual behavior matches the expected behavior, and this in a loop. It can be defined as a collection of techniques that select or help select inputs in order to detect or identify these boundary candidates, which then can be used clearly to extract tests from them and make the specification not only explicit, but potentially also runnable, right? And in our previous work, we've been introducing possibilities, some small algorithms that for boundary detection, and also hinted on the possibilities of how a visualization could be used graphically, also in terms of navigation within the spaces of boundaries. But that's a different subject than the one we addressed today, but that's certainly something where we can invest much more time on in the future. To make this concrete, let's look at a simple example of a software that could be tested, and for which we want to understand the actually bounds that an actual implementation is living up to. And this is the BMI, the table for the body mass index, where you're seeing that for certain weights and for certain heights, you get a certain outcome of BMI. And of course, you want to be somewhere in the green zone, which is the healthy zone. And this is just to show like the example of a sub that we can investigate and that we are drawing conclusions about where the boundaries are actually held. So we're detecting something and then we try to summarize it. And this is already an outcome then of the paper to show you the effect of this without knowing anything about the SAT in itself and without having an oracle or something. We just run our detection algorithm and it gives us the results. This is the validity group here, which means that I mean, the boundary candidates are always two inputs that are very close to one another and then their respective outcome, right? And they define a boundary because the outcomes are very different to one another. Inputs very close, outcomes very different to one another. We describe this theoretically also, but just for the talk, I think it totally suffices to take it on that level of complexity. And then we have the input pairs here, height and weight here, all of them. And the output for that, it's some kind of classification, you could say, in this case, because we don't only look at the numbers that come out, but the classification. And then we see the neighboring pairs, right? And this is both the detection. In the detection, you get a lot of points, and then this is summarized and filtered already through our method. And what's interesting with this is that, of course, we're seeing some rather weird points here, right? Like if you have a height of 1 centimeter and a weight of 0, well, then you're underweight. And then if you gain 1 kilo, then you're severely obese. This is a boundary that we're not expecting because this is kind of it's some kind of a consecutive spectrum that we're expecting. But this also shows that the software that we're running this on clearly hasn't thought about the inputs range in a more sophisticated way. And this can, of course, lead to propagation of errors. If you happen to have wrong inputs, you can get really weird outputs. So it helps us revealing certain situations that might not have been thought through, expected, and can be fed back then to the specification. Sometimes this can be covered then already by the developer or tester and say, no, I mean, no human is smaller than this or that. Or it has to be lifted up all the way to the product owner, and the product owner makes the decision about what's to be done. Then you can run the detection again and hopefully find more coherent and useful summaries. This is the paper that I talk about. It's a preprint. It's currently under revision, and the questions that we're trying to answer is, firstly, can we, for a rather generic sub that we don't know too much about, we have some assumptions, but that we don't know too much about, can we find large quantities of these boundary candidates? And how do the different strategies that we're applying here actually compare to one another? And then what's more interesting is, can we actually find different ranges of boundary candidates, not only re-identifying the same kind of category over and over again? And then the most interesting one here would be to ask, can we find relevant behaviors that actually a human or a tester would think is interesting, and could even be potential faults? That would be the most interesting findings. And how do we do this? One of the overall problems we're having is that we are in testing, we can make ourselves dependent on oracles, because if we do unit testing, for instance, we usually have an input and an output, and we have to know what the expected output is in order to make the match, right? And so this cannot be easily generalized because we don't know nothing about the subs that we're having in front of us. So what we've introduced in 2019 is the concept of the program derivative, which instead of looking at the absolute outcome of things, we're looking actually at the difference between very close inputs and the outputs of very close inputs. And that is what guides our search in what we in those points that you've found, that you've seen before, they are derived by this. And examples of these metrics that we could use are based on information theory, but you can also use very simple ones just to make the point. And also in this paper, we use the absolute simplest one, just in order to really show that this can work even with the trivial way of differentiating the output. And that is the distance of the string length, actually, of the output that you're getting. You can always stringify your outcome, and you can look at the difference. And to give you an example, one of the subs that we looked into is the date sub. Well, you have the 30th of April 2021 is valid. It gives you this result. But then if you enter the 31st, it's not a valid date, then you get an error message, and you'll see that the string length differs. So you have a substantial difference there, just to make the point. And of course, then you can gather a lot of boundary candidates, but you also have to make sure that they're meaningful. Are they interesting ones? So it's not only about detection, it's also about summarizing. That's why in our work, we have focused mainly on the detection part and not so much on the summarization part, where we use a simple method based on k-means clustering, which generalize pretty well in our examples, at least. What we've done is we've proposed two algorithms for detection. We used the most trivial program derivative that we could think of, which included the string length distance in the outputs. And we did this on 4 sets where we did a rather intense quantitative but also qualitative analysis. And in the revision that we're making right now, we're including another 200 or so sets that we extract from the base library in Julia, programming language Julia, in order to extend this with like a more broader spectrum. But there we only look into the quantitative measures, not so much the qualitative measures. And this is in this specific first study, this is limited to unit tests, and it's limited to integer-based inputs. And yeah, we can talk more about how this can generalize. We're working on that already. And some of the outcomes here, if you're looking at the 4 sets that we're having here, this is a date sub, then we have the BMI, the classification, and the BMI in terms of numbers, where you actually get the actual number as output in a mathematical formula. And then we have another one, byte count, that's translating incoming integers into like human readable byte descriptions, MB and DB and KB and so on. We have the 2 different strategies that we are applying in our work. LNS is very simple. It looks just into neighborhoods and boundary crossing searches, doing something more advanced, doing some semi-smart search. And what we could identify through the clustering of all these points that we've collected is that there are actually 8 different clusters. You could say it's 8 different groups of different candidates that could be identified for byte count. 15 for BMI class. You remember you had the move over from obese to severely obese and so on. Those were these 15 classes, and so on for the other sets. And we could see that we could identify. In most cases, we could actually identify rather, in here, we can identify all of them in 600 seconds, even 30 seconds, we can identify all of them with the second strategy. We get some pretty good coverage for the sets that we are looking into. So we're hopeful that we can, by even improving our measures, not only using string length dist, get even better and more specific groupings. I cannot look into the groupings here because of time restrictions, of course, but this is just for you to look into the paper and look at the specifics. We have the summaries all there. But overall, so we found interesting, what we would consider interesting points in all of the 4 sets. And the work that we've done is the first, to our knowledge, automated boundary value analysis, which is black box. So you can use it both for regular systems, but also AI systems, like more traditional, but also AI systems. And it's non-formal. It's just based on an actual implementation. And it doesn't require specification per se. And we've identified the potential for improvements, of course. And I already mentioned AI as a potential area of application. And actually, we're working on a research council funded project together, Robert and I, which is just about that, how we can apply these methods on detection and summarization of boundary candidates, even to AI software, machine learning, oftentimes. And so it's not so much about when do we want somebody, like this is a classical trolley problem. You have a trolley, and the question is, should you hit the switch in order to kill one person instead of 5, right? This is kind of a conceptual philosophical situation. What we can do with our software is that we can actually identify what the system is actually doing right now. Where is the boundary, right? Does it do that at 2, or does it do that at 3 persons, or 100? We can find out by our tool that we're using. So in terms of future collaboration, I want to make this short now. There are different venues to go. Distance metrics can be adjusted, extended. We can look into memory use, execution time. Because we don't do white box, we can at least get other kinds of information. We're looking more into the summarization aspects of this, because you get a lot of boundary candidates. How do you summarize them fast and efficiently? We are looking into potential ideas about GUI handling. How can we actually identify through our method unexpected, maybe even crashes in GUIs? And also looking into the process in itself. How do we include the tester in this? Now we're in an early stage. We're looking into detection algorithms, summarization algorithms, but how does it fit into the workplace? How is the tester of tomorrow going to sit down in front of their computers, and get started with this? And do they get kind of hints, tool tips or something? Do you want to look into that? How should that process look? So that's basically what I had. Thank you for listening, and hopefully you have some questions and thoughts.